Welcome to Kit Maker. We're going to dive into the pinouts and unleash the power of Antigravity AI to spin up our code. Welcome back to the channel. Let's get into it. First up, let's unbox this display. This ST7789 LCD is a popular choice for makers. It's super affordable, and there are plenty of open source libraries out there to get it up and running. First, let's identify the usable pins on our M5 Cardputer side. Next, we map them to the corresponding pins on the ST7789 display. And here is the complete schematic. Take a quick screenshot or grab the high-res file from the link in the description below. Time for some hands-on work. We'll start by prepping the LCD side on a breadboard using jumper wires. We'll leave the M5 side disconnected for now until our test code is ready. To kick off the software side, I'm feeding Antigravity just two things: our PlatformIO.configuration and a text file of our pinouts. We'll prompt it to generate a simple boilerplate script just to test the display. Once the code looks good, I'll tell the AI that PlatformIO is already set up on my system. I'll have it compile everything and generate the binary file, so we can upload it directly. The build finished successfully without any issues. Now, let's hook up the M5 Cardputer to our PC via USB and fire up the PlatformIO upload command to flash the initial test code. Now that the Cardputer has the test firmware loaded, we can finish the remaining wiring on the M5 side. Double-check every single pin connection here to make sure we don't short anything out. The color loop is working perfectly. Now that the display is alive, let's make it look cooler. I'm prompting Antigravity to design a dynamic text display featuring our channel name, Kit Maker, and we'll see how it handles rendering custom graphics. Let's plug the USB cable back in and run the upload command again. Let's watch this compile in real time and see what kind of digital magic Antigravity is going to conjure up for us this time. Check that out! It generated a scrolling Kit Maker text animation bouncing up and down, completely framed by a cycling RGB border. Not bad for a quick AI prompt. The animation looks great, but the screen orientation is currently locked in landscape. Let's send another quick prompt to Antigravity to adjust the layout and change it to vertical portrait mode. The new code is generated and fully optimized. Let's trigger the PlatformIO build tool one more time and flash the updated portrait firmware onto the board. Alright, we successfully changed it to a vertical layout, but there's a slight catch. The entire display is upside down. Time for a quick orientation fix. No worries, this is an easy fix. We'll just prompt the AI to rotate the screen layout by 180 degrees, then we'll follow our exact same build and upload workflow to patch it up. Perfect. Now it's displaying exactly the way it should. Now, for the ultimate upgrade, the touch functionality. I'm asking Antigravity to completely rewrite our codebase so we can drag the Luke Kit Maker logo across the screen using touch inputs. The AI is attempting to pull in a third-party touch library for this. Code is done. Let's compile it. Uh-oh, looks like the build failed. The external touch library is conflicting with our existing setup and crashing the compiler. Recognizing the bottleneck, Gemini pivots, deciding to scrap the library entirely and rewrite the touch logic using native primitive commands. And that did the trick. Writing low-level native commands directly bypassed the messy library dependencies, and the project compiled flawlessly this time. Let's push this final firmware to our cardputer. And here is the final, fully functional result. We can now use a stylus or our finger to smoothly drag the Luke Kit Maker logo anywhere on the screen. The response time is incredibly snappy and fluid thanks to that native code optimization. Pairing AI with low-level troubleshooting saves an immense amount of development time. Don't forget to like, subscribe, and I'll see you in the next project.